All right, we're going to talk about change in velocity. So we're looking at a problem where a man walks at 5 meters north, turns around, and walks at 5 meters south. And we want to know his change in velocity. Now, one of the things that, even before looking at the question, that tells us we're talking about change in velocity is the fact that one action comes right before the other one. They're not happening at the same time. There won't be a resultant velocity because I don't have two things happening simultaneously. I just have one thing happening, something changes, another thing happens, and we're interested in that change. So, looking at the initial velocity of the man, it's 5 meters per second to the north, and his final velocity is 5 meters per second to the south. Now, if we look at our formula for change in velocity, it's final velocity minus initial velocity, and we're tempted to just take 5 minus 5 and get 0, but that's not true. Something else is happening. Because these two things are vectors, this one's south, it points down. Because these two things are vectors, we have to take into account the direction in which they point. We have to do this vector math here. Now, the negative v0 is a whole different vector than v0, so we have to take and change it. So if we come down here and look at the opposite of v0, well, the opposite vector is the vector that's the same magnitude and just points in the opposite direction. So it's an additional 5 meters per second south. And if we look at the change in velocity, that's going to be final velocity, which we said was 5 meters per second south, plus this negative initial velocity, it goes right there, which is also 5 meters per second south. So when we do all of that, our change in velocity comes out to be 10 meters per second to the south. All right, well, that's one way to look at it. So what we're going to do is try it a different way. So if we look at the change in velocity like this, we start off going 5 meters per second north, and we end up going 5 meters per second south. The change in velocity is that thing that happened in the middle to get us going 5 meters per second south. So if we think about it, in order to go from 5 meters per second north to 0, I have to do 5 south. And then in order to go from 0 to 5 south, I have to do an additional 5 south, which is the same thing we did up here, getting us to 10 meters per second south. We're going to look at another example of that. Let's say we have a car that drives at 30 meters per second east, turns, and drives at 40 meters per second south. What is the car's change in velocity? Now, again, we can't just look at this and go, okay, I know that change in velocity is v final minus v initial. So I'm going to take 40 and subtract 30 and get 10. We can't do that because, again, these are vectors and they have a direction, and that direction is very, very important. So looking at it this way again, our change in velocity is going to be our final velocity, which is 40 meters per second south, looking at it like a vector, minus our initial velocity, which was 30 meters per second east. And because we're subtracting it, what that means is we need the opposite of that vector. So we've got 40 south plus, because we're going to apply this negative sign, it's going to give us 30 meters per second west. And then when we put those two vectors together, we go 40 this way, 30 this way. And so our resultant velocity is 50 meters per second. And the angle is going to be the angle is going to be west of south. And if you look at our original vectors, we had east and south. Because we're subtracting that one, it has to reverse direction. It goes into being west of south. If we look at it the other way, where we have our initial vector, 30 meters per second east, plus whatever our change in velocity is going to be gives me 40 meters per second south. When looking at the change in velocity like this, sometimes it's good to think of what you have to do to change this vector to make it look like this vector. And if we were going to make this vector point down, we'd have to push it to the south, obviously. That would only get us so far, and we'd have to continue pushing it to the west. So overall, we'd be pushing the thing this way, because we had a southward component to our pushing and a westward component to our pushing. And we still get this idea of having our change in velocity being west of south.